Okay, electric arc, flash, and a blast. Oh, Tom.
So we talked about the effects on the human body with regard to shock, and we migrate always to defibrillation, and we talk about let go. So I saw a presentation that was conducted by a gentleman who was suffering from sequela. And sequela is a condition that he had that he gained over years of minor shocks where he said as an electrician, over the years, he would come in contact. And like you said, you feel that tingle and you walk away and you go, wow,
Yeah.
boy, And then he says that he worked on a lot of like HVAC equipment and whatnot, and he would constantly get shocked. And no one ever reports that.
Right.
Well, there's a doctor, and what was really interesting was during his presentation, you know what he said? Current through the body doesn't pass through the heart.
No.
Current through the body takes all paths, which includes your brain, which includes all of your nervous system. And what he has shown in his research, and he had videos of subjects who would walk across the room, and this is a person who had been subjected to shocks their life, right? In
Not just one shock.
Right, many,
Right,
over
many
and
shocks,
over.
right.
And she was walking across the room perfectly fine. And he tells her, go back. Now close your eyes and walk across the room, and she couldn't keep her balance. Her system was reacting, and she was damaged through the nervous system, through the brain, all this other good stuff over those years of shock. And you take that individual, put them on a ladder, put them on scaffolding, they can't keep their balance. And his message was, look, his research has shown that it's not just the let-go threshold. It's not just the defibrillation. Those continuous shocks that are never reported, that many electricians experience over their life, is damaging their body in ways that they don't manifest themselves until much later in life, when all of a sudden they get they have to put their foot on the ground when they get in the bed because they get that what do they call it, motion sickness type of deal, right? Vertigo, where they get vertigo, and they can't define why I have vertigo. And this individual who did his presentation was suffering from it, and he had seen so many different doctors, and they could not solve his problem until he met this one individual who was doing research in this, and they tied two and two together.
You're bringing out a point that I wasn't going to make here, and hopefully I would have made, and I don't think I would have done that, and that is, listen, apprentices, or those people that are new in the industry, there's this macho attitude in the electrical industry. We don't have to torque. We can work on it hot. We're fine. You're a baby if you don't. And my son's an electrical contractor, and I told him, I said, Michael, do not work on it hot. Okay? I don't care what your situation is. You might get fired. You might be mocked at. You might be whatever it is. Your daughter doesn't care if you work in McDonald's and you come home every single day safely. Yeah. So those of you that are listening to this, you're going to be intimidated and pressured. These guys, they don't understand. They were brought up in a generation that you worked on it hot and it's fine. And I've been shocked, I'm fine. And what you're bringing out, Tom, is say, look, it's like football, right? Players with a concussion.
Yeah.
It's one of these things that might not manifest itself until later on, and we never even considered the possibility because it was the practice to allow this. So do not touch anything hot. When I mean hot, I mean the circuit is energized. You turn it off. We're going to talk about this in PPE in a little bit, but just tell them, no, I'm sorry. I'm a baby. Yeah, whatever you want to call me. Okay, I'm not doing that. I'm not going to get shocked. I'm not going to get involved in that. Eric?
Yes, Tom mentioned the word sequela, which comes from sequence or sequel. It just means that which follows. And so the medical conditions you're talking about follow the electrical shock. That's 1793.
Okay. Wow. All right, we're moving on. Electric arc, flash, and blast. All right. Here is a video.
I'll show that actually. Let me show that on my computer so it doesn't bog you down here.
All right, there. This
Really
is a
cool video.
Great video. This is an arc flash And then I'm not sure. We have two things. Let me know when you're ready, Brian.
I'm ready.
Okay. There are two things. There's an arc flash, which is just bright light of 30,000 degrees, hotter than the sun, and whatever the case may be like that. And then it's like popcorn. What happens when you have a little kernel of popcorn? You heat it all up. It does what? It builds pressure, does what? Then it pops. Well, when you have an arc blast, it's like lightning. You hear thunder. What is that? Well, that is just simply an arc blast. That is the concussion of the expanding air. And we'll have videos here, maybe we'll show it here, where a person actually is thrown back. And the National Electrical Code and the 23 code is talking about working space. When you work on equipment, that working space in front of you, it might throw you back into equipment behind you that might already be energized, working on equipment both sides. So arc blast is the air, the expanding air that's going to be pushing out like a popcorn kernel, just exploding. All right, Brian, we'll go ahead and watch your video. Oh, we saw him move.
All right, so it's going to replay here in slow motion, and we can see what happens.
That wasn't that big of a deal, you know. Okay, there you go.
It wasn't because we couldn't see what was happening. We've got molten metal.
Well, you can see the blast come out of that.
And there's not much time to think.
No, and because if they hadn't had that person secured to the ground, that person would have blown back.
That's a good example of wearing fuel instead of personal protective equipment.
Yep.
Yeah, wearing materials that ignite.
Yeah.
These are all fairly common scenarios that they're showing here. I actually picked this video because of that.
And you know what I like about that last one there was, you know, you say, I have my personal protective equipment on, and you're on a ladder.
Oh yeah.
It's that fall, right? It's that.
Which could be worse.
Yeah, exactly. You know, you're pushed off of a ladder and you fall
Well,
off of a.
and even if it's not the concussion that pushes you off, just being startled.
Absolutely. That's why
shock.
just the tingle, you know, you have that leakage current that's flowing and you get that jolt that.
Go ahead and come on back to yours. We just got another nice little sequence
All
I
right,
want to
I
show
can't do
here.
yours. You got to do it.
Oh, sorry. All right, another nice little sequence here where you can actually see. And that's how many feet back in each of those marked on the back wall there. 1, 2, 3, 4,
Oh,
5.
the feet.
Wow.
It's your arc flash boundary.
Yep, that was your arc flash boundary.
And we'll be talking about that.
Yep.
All right, take a look at the slide here. Here's an example. Something happened here. By the way, this is called the line side. Coming in as line, going out as load, and that's the practice. You can see on the line side, before it goes to the breaker, that there was a fault. And you can imagine a person standing there. This is just examples. This is not really an arc flash, because it would be, you saw what Brian showed in the video, would be a lot bigger and brighter and more intense. This is just like whatever. And this is just, again, an actor, okay, put some fuel on the person. During an arcing fault condition, electrical energy is converted into various forms of energy. Electrical energy can vaporize metal, can change from a solid state to a vapor. When copper is vaporized, of course, same thing with aluminum, it expands its volume and creates a superheated plasma. So here's going to be an example of a mannequin. Now you can just see how that thing is jetted out. And this thing is, whatever, 30,000 degrees, and you got plastic and Bakelite and wire insulation and paint and steel and copper and aluminum. All this thing is converted now into a vapor. And the problem, beside obviously the heat, is that that can go into your lungs. I mean, the lungs is a pretty big deal. When you start cooking the interior of your lungs, and obviously you're maybe not going to die necessarily, well, you might. But you're going to be now forever limited in your breathing capacity, and that's always a big problem. Also, looking at this slide here, Tom, we don't have the time to get into this, and this is not the place, but it's the configuration of the wires and the way I call
bars.
buses, the way things are inside enclosures and the size of the box. I mean, if you're in front of a box and it's there, Well, it isn't like you're in an open room and this thing goes out in 360 degrees, right? Or whatever, whole sphere. No, this thing is hitting something and you can see it, and you can actually see a jet. I mean, just happened to work out that way, that jet. And that jet could have gone down, it could have gone whatever it's going to be, it's fitting the face. Here's some real pictures of somebody was standing there. This is I got the photos, the original photos. Here's the hard hat and what do you call that? Baklava? What is this thing?
Baklava.
Baklava is dessert. It's dessert.
That's where my head's at. My head's
You
at the
just did-
baklava, but
Balaclava.
balaclava.
You did it on purpose. I know that.
Always do.
I know that. All right. So then here's the person's hands. They didn't have protective. And I have a picture of the actual person's face. You know what I mean? But it's like, we don't need to. Because it's like here.
Yeah.
You know what I mean?
There was one image that I thought was really good, that it showed the personal protective equipment was damaged right here.
Right.
Right. You could tell he took the brunt of the energy right on his shoulder.
On the shoulder, yeah.
But when he's laying in the hospital bed and you're looking at that shoulder, it's not, there's no black marks, there's no skin that was burned. But his face, his ears, and everything was burned and charred because he wasn't wearing his balaclava. He wasn't wearing the rest of his personal protective equipment. If he would have had that on, he would have been able to walk away from that without having to go to the hospital outside of a checkup, right?
Right.
And there was a study done at a workshop, safety workshop, over a series of 4 years, where they wanted to research if we're calculating the right energy and are they wearing the right personal protective equipment. And the takeaway was, people aren't wearing all of their personal protective equipment.
Oh, not all of it.
Ooh.
Right. So they did this research thinking, okay, we took all of these cases, all these instances, we want to look at the PPE, we want to look at the calculated energy. And they said, well, he wore his jacket, but not his hat and his balaclava. He wore
False
his,
sense of security.
yeah. And then the one,
You
the
can't
one
choose and pick.
Right. The one company that I talked to, they wore personal protective equipment from the waist up because they said, we're working on equipment that's mounted from the waist up. And they didn't realize that the energy goes down too. Right? So they didn't have their pants and their shoes. And they were wearing flammable clothing on their torso. So when you do that research and you realize we're not wearing all of our personal protective equipment, it's very critical to do that.
Well, this is an electric meter, and of course you can see it right here. You can see this was a serious event that takes place. Now, 35,000 degrees, whatever. Brian, we need to do a better job making a graphic here. This is kind of hokey. You know, I mean, it's okay. The concept is that there's an explosion, it spews it out. Okay, that's great. Now, there are labels, and we're going to talk briefly about that, that there's a standard, and we really didn't talk about this, NFPA 70E. The code book is 70, 70B. Tom, the title of 70B is what? We talking about the torquing?
Recommended practice.
Well, currently it's a recommended practice for maintenance of electrical equipment, and I'm paraphrasing
Okay.
that. I'd have to look at the exact title, but it's moving to a standard in this
Okay, so
next edition.
one is maintenance, this is electrical installation, it's 70, 70B, now there's a 70E, and 70E, the title of 70E is?
Electrical safety in the workplace.
Standard.
Electrical safety.
Standard for electrical safety in the
Standard
workplace.
for electrical safety.
Which, in what you're saying, there's 4 levels. There's the code.
Oh, okay.
There's a code, which is the NEC.
I did not know this.
There's a standard, which is 70E for the workplace. There's a recommended practice, which is 70B, and then there's a guideline,
Okay.
which 1584 is a guideline, for example.
All right, so 70E gives us information about labeling. You mentioned a couple words, I let you go with it. You say, well, PPE, and you said incident energy. You know, Tom, what you said. Well, PPE is personal protective equipment. You're saying they're not wearing all their PPE, right? They're not wearing all the personal protective equipment. And the other one was the incident energy. Was like, well, Brian, you showed the video. We could actually measure that heat.
Yep.
And how far did that heat go out, and how much heat does it take to burn you? So
Second
there's
degree burn.
calculations. Okay, well, it's 1.2 calories per centimeter squared, I think it is, right?
Yep,
Yes,
Per square
yes.
centimeter, yeah.
Per square centimeter?
Yep.
1.2 calories per square centimeter?
Which is the threshold for a second degree burn.
So that means that a second degree burn is 1.2 calories. Well, whatever it's going to be, okay? 1.2.
What's the second degree burn?
question.
What does that mean?
What's a secondary burn? I think a secondary burn is where you actually now, first, see, first, second, third. A first degree burn is like a sunburn, right? You actually don't damage the skin. We need to, Eric, find out what's a second degree burn, because that's like, okay, well now you actually have damaged the skin, but we need to find out
It's curable.
it's curable.
It will heal.
It'll blister, but it'll heal.
Right.
Yeah.
And you haven't penetrated the skin.
We haven't penetrated
layer.
the skin. We
Once
just
you-
heat it up.
It's not
We
subcutaneous,
blistered it.
right?
It's
Right.
gonna. Okay, so we're
You
like,
haven't gone to the muscle, right? So you haven't gone past the skin into your tissue that your skin is protecting, right? So when your burn passes through that, now they have to do grafting. So what they try to prevent is, or what they try to ensure is that you have a curable burn, okay? They're not saying that your personal protective equipment, that you're gonna walk away and you may not blister. They're just saying that if you do get burned, it will be curable. It won't be the third degree burn that is,
Medical attention. You need
Maybe-
you need
you need
medical attention.
grafting, you need
yeah,
all
this
kinds
right
of
here.
stuff.
This might be a second degree burn.
Could be.
Could
It's hard to tell from
Right.
from pictures.
We
too.
won't know that until
A doctor tells you.
we look at it. Okay, so back to where we were. Okay, so now this label tells us what? Now we know it's 1.2 calories is okay. Above 1.2 is not okay because that's secondary. This right here is 22.8. Well, okay, right? We have a major problem, which means we have to do what? Now we have to have the personal protective equipment, PPE, that is designed to accommodate that level of energy and heat so that we don't get more than a second degree burn inside that. Brian?
I just want to make a comment. You said 1.2 calories is okay, and that's not really a great comment to make, because while 1.2 calories might be okay if your skin's exposed to that, there are still some risks at 1.2 calories if you're wearing improper clothing or contaminated clothing, that your clothing could catch on fire at 1.2 calories. So you can't just say 1.2 calories is okay, because there's still a risk there. So you always want to be wearing FR clothing in a
Well, I
scenario.
don't know what FR means.
Fire resistant, flame retardant.
So in
fire
other
resistant.
words, yeah, well, you might not get to the muscle, but you're wearing clothing.
Well, it might not even actually burn your skin in some cases, more than just a
Well, the
little,
calories
like
are
hot water.
irrelevant then, as far as what you're wearing could ignite.
Correct. So
What
just
you're
when you
saying.
said it's okay, it's just like,
Well, it's okay
well,
for the skin,
it's okay for the skin, but
but it's not okay
there's
for
a
the
lot
event.
of other factors. You know,
This way, I still wouldn't want a second degree burn.
No, yeah, no, for sure.
Baby,
Yeah, not this guy.
baby. All right, back to here. So, what NFPA 7E says is like, and it's not a requirement to put this on equipment. This is just a standard. That if we had the labels, then it allows the electrical professional to know that we need protective equipment here. And it also gives an instant energy and a boundary, which we're not going to be getting into this much detail. So, arc blast, an arcing fault can generate an arc blast, which we see, and that's the concussion. The strength of the arc blast creates an explosive pressure wave that can inject shrapnel, molded metal, plastic, paint across the room and cause severe injuries or death to persons who are close to the blast. So we not only have, Brian, you said, okay, wait a minute, not really the right word to use. Okay, fine. We not only have heat that could be a second degree burn, we have heat that could ignite clothing that's not designed, was never intended to be at that temperature. When you go to the beach and you wear a sweater or you wear whatever your hat, whatever it is, that we never thought we were going to be anywhere near a heat source. Then we also have now this explosion. And the most important thing I can say is you just don't work on it.
Yep.
You don't put yourself in the position, and anybody that has to work on it for, when I say work on it, but it has to open that enclosure to get exposed to the light parts, that person has to be super qualified.
Yep.
I mean super qualified, that would know what you just said. Well, Mike, it's not really okay. I mean, you got to understand the FR rating, okay, the fire resistant rating. You got to understand that there's a blast.
How to
there's
read the
electric
label.
Shock, let's put it this way. You can't read that label? oh, you're definitely not qualified.
That's right.
Well,
That's right.
and you know, we're spending a lot of time here on this one particular area of this label, which is arc flash / blast. But the reality is the risk is actually far greater that you're going to get shocked than an arc flash, arc blast in
exactly.
the industry. Like this is, as much as we like to talk about it because it's exciting and flashy and things blow up and catch on fire, the risk is much, much, much higher that you're going to be shocked and or electrocuted than be involved in an arc flash, arc blast incident. For our scenario, which is, you know, 80% of the electricians are working in a house with a very low potential for this to happen, but they could certainly get electrocuted in that scenario.
And that's why it's really important when you tell some, like you talk about the qualifications and either reading that label or understanding what the labels are from arc flash, establishing an electrically safe work condition, you're assuming it's energized.
Yeah.
And you have to treat it as if it's energized. So just to simply establish the electrically safe work condition, you need to understand the equipment that you're working on, you need to know how to establish that condition, and you need to dress appropriately. So no matter what you do,
And there's technically
you've got to be very qualified.
there's technically no
be able to do that work.
scenario where you're ever actually electrically safe.
Yeah. Yeah.
Well, right, and I was going to bring that up, that people have died. People have gotten electrocuted in what was called an electrically safe work condition. So an electrically safe work condition says that it's supposed to be de-energized. You're supposed to find the sources.
It's a procedure,
You're
right?
It's a procedure.
It's a procedure.
And then it's just simply a title, electrically safe work condition, but it doesn't mean it's safe because, as you know, most shocks come from, for example, lifting a neutral in a multi-wire Brent circuit or what have you. The neutral becomes energized, and many people have died from this, and that is not covered in NFPA 70E.
All right, let me try to say what he said. If you don't know what he just said, then you're not qualified. Right?
Yeah.
I mean, if you don't
that's
know what
simple.
he's,
Yes.
If you don't know, well, how do you make an electric safe work? Well, Mario said, well, that's a procedure. Yeah, that's a procedure, Mario. And then lifting a neutral, Listen, this is a big deal. Beside the arc blast, like you said, it's, you know, whatever. The electric shock is the greatest hazard, and you brought up the scenario like, well, this is another one of those events. You know what I mean? We keep adding that sequentially, adding that up inside here. Guys, we don't work on anything hot. You need to understand, Brian, as Michael Enterprise, we do a terrible job on 70E and a practical thing, and we're going to do a better job of giving you something. Okay, well, how can I know what's an electrically safe work condition? How can I know the hazards? How can I put myself to be in a scenario where I can feel safe? And as an industry, you know, people need to seek out. So how can Tom, Brian, Eric, real quick short version, how people can right now, what can I do to get something practical so that I can learn more about this? Because that's where I want to take
The
it to.
first thing, you think about the journey of those who are watching this video, right? They're
Yeah.
new into the industry. Their primary focus needs to be to understand everything that we talked about in the last few sessions, right? Recognizing voltage, recognizing that voltage is present on a receptacle. What am I exposed to? And just realize that's dangerous. You saw the ramifications of shock. You see the ramifications of arc flash. You don't need to know at this point in your education
Right.
what can give me an arc flash, what can give me a
Right,
shock. You just
right.
know it's not good
Awareness.
to touch that. It's awareness. You want to be awareness of being able to recognize
And I think
that.
our apprenticeship program
Well,
has modules
so
for that.
One of the things that I have been very passionate about is I've kind of redesigned our curriculum is to make it practical for, you know, let's just say you're a first year apprentice and this is part of the work that you're doing or wherever you're at in your journey. You know, we have included an entire module on how to use a multimeter.
I forgot about that. Yeah.
And the reason that we've done that is because there's no way for you to know if you're at risk if you don't know how to check to see if you're at risk. You can't see electricity, you can't smell electricity, you can't hear electricity that you shouldn't be able to. And so, you know, there's got to be some way that you can be safe. And again, the risk, I think, you know, at this point if we're just saying someone's just getting into the industry, the risk at this point in the career is that they're exposed to a danger that they're unaware of.
Right.
Well, you
And-
know, I had a direct message from somebody on Instagram, and he was all excited, you know, to contact me. And he'd been in the trade for 3 years. His grandfather's an electrician, And he told me how he just hooked up something the first time hot. And I said, okay, that is a major problem that your uncle, I think it might have been a family member, whatever it was a family member, that your family member taught you and even supervised you working something hot. I said, that person needs to have some training because that was the most dangerous thing he could have ever done. And of course, the guy now goes, Instagram, and what a terrible person I am, and you don't know what's going on, and who do you think you are? And it's like, you can't even explain to somebody who's learning from somebody that they have confidence with, that they trust, that it must be okay because you're showing me how to do that.
Yeah.
Mario?
Yeah, and that goes to your point. Don't let anybody brainwash you. Don't let anybody impose their will on you. Like, learn what we're saying
This is
here.
your body.
Yeah,
Well,
and put this to practice.
You
That's why
know,
it's a
Mario,
culture.
it's not that. Nobody's trying to brainwash anybody.
Just the way we do
okay,
it.
so let's put this in perspective. I'm a third-generation master electrician. 8 years old, I was putting receptacles on Romex in houses, helping my dad. This is a massive paradigm shift for our industry.
It's true.
Right.
That's true.
Okay, I will honestly say here that an accepted practice for me to find out if something was hot was to take your finger and tap the wire and see if you got shocked. I mean, that was a normal part of my day, and never at any point in time did I consider that to be a risky behavior, and nor did my dad or his dad. This is, as times have changed, okay? We didn't even have meters to carry around 70 years ago with us everywhere we did electrical work. Couldn't afford it, didn't have the tool, didn't care, right? It didn't have the scientific knowledge or understanding, certainly didn't have formats like we have here where we've got laptops and the internet and DVDs and books and all these other kinds of things. So this is actually a culture shift. And you
Yes.
know, his dad and his grandfather may not even have a clue that what they're teaching him how to do is not safe and was never safe because they were never educated because it wasn't available to them.
All right, we got to get back to work. We've got to
Yeah,
finish this program.
Yeah,
Art?
real quick, a good friend of mine said, look, Eric, doing electrical work is basically a hide-and-go-seek game with death. Your job is to find death before it finds you. And just constant awareness is what it boils down to, constant.
Listen, I'm not trying to freak you out. Actually, I am. Okay. We talked about the excitement of solar and all the lighting and all kinds of stuff. We need to be careful. We need to be safe. And we need to protect other people. That's part of our responsibility.